Now we will be discussing about kinematic equations for uniformly accelerated motion. Now, coming to the definition of kinematics, kinematics is a branch of mechanics which describes the motion of the objects without considering the forces that cause the motion. Now, I will be deriving some simple equations, and those equations will be consisting of these following terms. My dear friends, let us assume at time t is equals to 0 seconds, the initial velocity of the object is v0, and after some time t seconds the velocity of the object is v. Now, coming to the definition of average acceleration is equal to change of velocity divided by time interval. This is the definition of average acceleration. Now, in this case, we have already assumed that this is a uniformly accelerated motion. As the motion is with uniform acceleration, we can say that average acceleration is equal to the constant value of the acceleration a. So, a is equal to change of velocity, that is final velocity minus initial velocity. Final is v minus initial velocity in the time interval of t. So, I can write this as v minus v0 is equal to at, and v is equal to v0 plus at. This is the first equation. Now, I can also represent this particular equation graphically. I am going to draw the graph for this equation. On x-axis I will take time in seconds, on y-axis I will take velocity, and this is the origin, that is t is equals to 0 seconds. We have that at t is equals to 0 seconds the velocity is v0, and I will take here v0, and after some time t seconds, for example this is t, after t seconds the velocity is v. The value of v is nothing but v0 plus at. So I will plot this point v0 plus at. At t seconds v0 plus at. It will be somewhat higher. For example, let us take here. This is the point. Let us join these 2 points. So this is the graph which represents this particular equation. Now, we already knew that the area under a velocity time graph gives the displacement of the object. So, if I find out the area under this particular curve, I will definitely get the displacement of the object in the time interval 0 to t. So, let's find out the area under this curve. To find out the area, I will draw an imaginary line here, and I will give some points A, B, C, D. So I have to find the area A, B, C, D. To find out that, I will draw one more imaginary line. This is the imaginary line, and this is E. So the upper part is looking like a triangle and the lower part is looking like a rectangle. So if I add those 2 areas, I will get the total area. Now let us write down area of ABCD is equal to area of the triangle ABE, area of this triangle ABE plus area of the rectangle AECD. Now area of ABCD is nothing but the area under velocity time graph, that is displacement x equal to area of triangle, half into base into height, half into base, this is the base and this length is nothing but t, so t into height, this is height, this is the height of this particular triangle, and we have this point as v. At time t the velocity is v, and this length is nothing but v minus v naught, v minus v naught. So height is v minus v naught plus area of the rectangle, length into breadth, length is t and breadth is, this is the breadth and the value is v naught, this is v naught. So x equals to half into t into, in place of v minus v naught I can write at from this particular equation. V minus v naught is equal to at, so here at plus v naught t. Finally I will get v naught t plus half at square. This is the second equation. Now I can also derive one more equation. I will derive here. The third equation is that, and to derive that equation I will take this equation, that is x is equal to half into t into v minus v naught plus v naught t. Let's do like this, half into vt, we will get half into vt minus half into v naught t plus v naught t, and x is equal to, we will get vt by 2 plus v naught t by 2, because v naught t minus v naught t by 2 is v naught t by 2. Finally we will get x is equal to v plus v naught by 2 into t. Now my dear friends, in place of t I can write v minus v naught by a. T is equal to v minus v naught by a. Let us substitute here. X equal to v plus v naught by 2 into, in place of t, v minus v naught by a. Finally x equal to, this is in the form a plus b into a minus b, that is a square minus b square, so v square minus v naught square by 2a, and this will give, that implies v square minus v naught square 2a into x, 2ax, and I will take this minus v naught square to that side, and that becomes v square is equal to v naught square plus 2ax. This is the third equation. My dear friends, these are the three simple equations. These equations are derived by taking one condition, that at t is equals to 0 seconds the initial position is x equal to 0. At t is equals to 0 seconds the initial position is x equal to 0. Based on this condition we have derived these three equations. And first suppose if the initial position is at x naught, if the initial position is at x naught, then there will be slight modifications to these equations and this will remain same v is equal to v naught plus at, and this will change as x equal to x naught plus v naught t plus half at square, and this third equation will become this will become v square equal to v naught square plus 2a into x minus x naught. So my dear friends, this is about kinematic equations. Thank you.